Hello everyone, in today's video we are going to talk about verifying trigonometric identities, and we have the warm-up, the lesson presentation, and worksheet number 2. So first, let us have the warm-up. So simplify the following: sine A over cosine A times cosine squared A over sine A. What is your answer? Correct, it is cosine A. And how about tangent A times sine A over tangent A times 1 over sine A? So in here, you can cancel. So the answer is correct. It is equal to 1. Very good. So that's the warm up. Now let's move on to our lesson. The objective of this lesson is to use the fundamental trigonometric identities to simplify and rewrite expressions and to verify other identities. You can use trigonometric identities to simplify trigonometric expressions. Recall that an identity is a mathematical statement that is true for all values of the variables for which the statement is defined. A derivation for a Pythagorean identity is shown below. So let us have a recall of what we have learned in the past. So using the Pythagorean theorem, x squared plus y squared is equal to r squared. So in here, we are going to divide both sides by r squared. So in doing this, so we have x squared over r squared plus y squared over r squared is equal to 1. And then we are going to substitute cosine theta for x over r and sine theta for y over r. So the result will be equal to cosine squared theta plus sine squared theta is equal to 1. And let us recall to the fundamental trigonometric identities that we have before. We have the reciprocal identities, we have the tangent and cotangent ratio identities, and Pythagorean identities, as well as the negative angle identities. To prove that an equation is an identity, alter one of the side of the equation until it is the same as the other side. Justify your steps by using the fundamental identities. So let us have example 1a. We are going to prove that tangent theta is equal to secant theta over cosecant theta. The first thing that we are going to do here is to change your secant and cosecant into its reciprocal identity, which is equal to 1 over cosine theta over 1 over sine theta. And then from here, we are going to simplify. 1 over cosine theta times sine theta. So remember, if we are going to divide fractions, we are going to change it to multiplication and get the reciprocal. So from here, we have sine theta over cosine theta, which is equal really to tangent theta, which is the ratio identity of your tangent theta. Now let us have example 1b. Let us prove that 1 minus cotangent theta is equal to 1 plus cotangent negative theta. So the first step is to have the reciprocal identity. So we have, since cotangent theta is equal to 1 over tangent, so we have 1 plus 1 over tangent negative theta. And the negative angle identity, so we have 1 plus 1 over negative tan theta. And from here, we get the reciprocal identity, so it is equal to 1 plus negative cotangent theta. Then simplifying, we have 1 minus cotangent theta. So let us have the helpful hint. You may start with either side of the given equation. It is often easier to begin with the more complicated side and simplify it to match the simpler side. So let us prove each trigonometric identity. Sine theta times cotangent theta, is it equal to cosine theta? So from here, we are going to have sine theta over 1 because we all know that any number has a denominator of 1. And then the reciprocal identity for cotangent theta, it is equal to cosine theta over sine theta. From here, we are going to eliminate or cancel sine theta and sine theta. So it will become cosine theta is really equal to cosine theta. Now, you can also use the fundamental trigonometric identities to simplify expressions. So if you get stuck, try converting all of the trigonometric functions to sine and cosine functions. So let us have example 2a, using trigonometric identities to rewrite trigonometric expressions this time. So let us rewrite secant theta times 1 minus sine squared theta. So from here, we need to substitute secant theta is equal to 1 over cosine theta. And then from our Pythagorean identity, 1 minus sine squared theta is equal to cosine squared theta. So in here, we are going to multiply. So cosine squared theta over cosine theta. And then we can cancel one of the cosine. So cosine, then cosine in the denominator. So simply, it is cosine theta. Now let us have sine theta, cosine theta times tangent theta plus cotangent theta. So in here, we are going to rewrite each expression. So we copy sine theta times cosine theta, and then we are going to have the reciprocal identity of tangent and cotangent. So tangent is equal to sine theta over cosine theta, while cotangent theta is equal to cosine theta over sine theta. So from here, we are going to multiply. Multiplying it, so we have sine squared theta times cosine theta over cosine theta plus sine theta cosine squared theta over sine theta. Then we are going to simplify. We can cancel cosine and cosine in the numerator as well as in the denominator, and the second fraction we can cancel sine theta and sine theta. So from here we have sine squared theta plus cosine squared theta. According to the Pythagorean identity, it is equal to 1. So we are going to rewrite each expression in terms of sine theta and simplify. So if we have cosine squared theta over 1 minus sine theta, in here, we are going to use the Pythagorean identity wherein cosine squared theta is equal to 1 minus sine squared theta. And then we are going to copy the denominator 1 minus sine theta. And in here, we factor the difference of two squares. So in the numerator, we shall have 1 minus sine theta times 1 plus sine theta. Then we copy the denominator. And from here, we can cancel 1 minus sine theta as well as 1 minus sine theta in the denominator. Simplifying further, we get 1 plus sine theta. So let us have example number 3. This is a physics application. So at what angle will a wooden block on a concrete incline start to move if the coefficient of friction is 0.62? So from here, set the expression for the weight component equal to the expression for the force of friction. So we have this formula. And then we are going to divide both sides by mass times gravity. So we get sine theta is equal to mu cosine theta. So from here, we are going to substitute 0.62 for mu. So we get sine theta is equal to 0.62 cosine theta. So let us continue dividing both sides by cosine theta. We shall have sine theta over cosine theta is equal to 0.62. From here, we all know that sine over cos is equal to tangent. So tangent theta is equal to 0.62. Using the calculator, pressing inverse tangent, so it is equal to 32 degrees. So therefore, the wooden block will start to move when the concrete incline is raised to an angle about 32 degrees. So before we are going to continue, let us recall some Pythagorean identities. So from sine squared x plus cosine squared x, which is equal to 1, we have sine squared x is equal to 1 minus cosine squared x. And cosine squared x is equal to 1 minus sine squared x. From tangent squared x plus 1 is equal to secant squared x, tangent squared x is equal to secant squared x minus 1. We also have the third Pythagorean identity, 1 plus cotangent squared x is equal to cosecant squared x. From here, we shall have cotangent squared x is equal to cosecant squared x minus 1. And then we also have 1 is equal to cosecant squared x minus cotangent squared x. So from here, we are going to verify other identities. So let us have example number 1. Supposing we have sine x times secant x, is it equal to tangent x? So from here, we are going to have sine x. Then we are going to rewrite secant x to 1 over cosine x. Is it equal to tan x? From here, we are going to multiply sine x times 1 over cosine x, which is, if we are going to have the denominator of sine x, which is 1, so sine x times 1 is sine x, over 1 times cosine x is cosine x. Is it really equal to tan x? We all know that tan x is equal to sine over cosine, so tan x is really equal to tan x. So let us have another one. Cotangent x times secant x times sine x, is it equal to 1? So let us rewrite cotangent x as cosine x over sine x times rewriting secant x as 1 over cosine x, then copy sine x. And then we are going to have over 1 because any number has a denominator of 1. Is it equal to 1? So from here, we can cancel cosine x, then we can cancel sine x. So therefore, 1 times 1 is equal to 1. Really, 1 is really equal to 1. That is example number 2. So in here, we are going to prove that cosine squared x minus sine squared x is it really equal to 1 minus 2 sine squared x. So from here, we are going to rewrite cosine squared x as 1 minus sine squared x. Then minus sine squared x, we copy. Is it equal to 1 minus 2 sine squared x? So from here, negative sine squared x minus sine squared x, it is equal to negative 2 sine squared x. So we have 1 minus 2 sine squared x is really equal to 1 minus 2 sine squared x. So negative 1, remember that negative 1 sine squared x minus negative 1 sine squared x, it is equal to negative 2 sine squared x. Now let us have other examples. So we have secant x minus secant x times sine squared x. Is it equal to cosine x? So from here, we are going to rewrite secant as 1 over cosine x. Then we are going to rewrite secant x as 1 over cosine x. Then we are going to have sine squared x over 1. Is it really equal to cosine x? So from here, we are going to have 1 over cosine x minus sine squared x over cosine x. Is it really equal to cosine x? And we have, because we have the same denominator, we can subtract the numerator. So 1 minus sine squared x over, copy the same denominator, cosine x. Is it really equal to cosine x? So we all know that 1 minus sine squared x is equal to cosine squared x. And then we copy the denominator, cosine x. So from here, we can cancel cosine x times cosine x. So we can cancel cosine x and cosine x. So what's left is cosine x. So therefore, it is really equal to cosine x. Now let us have another example. So for our last example, we are going to prove that sine x times tangent x is equal to 1 minus cosine squared x over cosine x. So from here, we are going to have sine x times, we are going to write tan x as sine x over cosine x. And then, is it equal to 1 minus cosine squared x over cosine x? From here, sine x has a denominator of 1 so that we can multiply numerator times numerator. So sine x times sine x is equal to sine squared x. 1 times cosine x is cosine x. Is it really equal to the right-hand side of the equation? From our Pythagorean identities, sine squared x is equal to 1 minus cosine squared x. So therefore, it is really equal to 1 minus cosine squared x over cosine x. So that is our example number 5 and our last example. So that's it for now. Don't forget to do your worksheet number 2 as your practice. So see you again next time. Goodbye.